Hello, you are welcome to my YouTube channel. In this video, we are going to be solving this interesting equation. So what are we going to do first? Now, I am going to reduce the exponent that I'm seeing here. Look at this 9, look at this 6. Let's see how we can reduce the exponent. How am I going to do that? I'm going to use power of a power rule. So this is going to be m raised to the power of 3 bracket then 3. If you multiply this 2 exponent, you will get 9 back. This is power of a power rule. Then plus, let's do the same thing here. M raised to the power of 3, then bracket 2. 3 times 2 will give you 6. So all of this is equal to 36. Now that we have m raised to the power of 3 here and m raised to the power of 3 here, why can't we just set it to another variable so that we just have reduced exponent? So we can say let t be equal to m raised to the power of 3. So if that's the case, then you now simply substitute m raised to the power of 3 for t. So it's going to be t raised to the power of this 3 here, and then plus, what about this one? T raised to the power of 2 is equal to 36. So let's move 36 to the left hand side. I'm going to have t raised to the power of 3 plus t raised to the power of 2 minus 36 is equal to 0. Now what I can do next here is to use the remainders theorem or the factor theorem to get one of the values that will satisfy t. So I can say for t is equal to 1, if you plug in t is equal to 1 and it gives you 0, then it means that t is equal to 1 is one of the solutions of this equation. Okay, so let us plug in t is equal to 1 into this equation and let's see what that will give us. 1 here raised to the power of 3 plus 1 raised to the power of 2 minus 36. This will not give us 0. So this is not a solution. What about when t is equal to 2? Again, substitute 2 for t here. So this is going to be 2 raised to the power of 3 plus 2 raised to the power of 2 minus 36. What is 2 raised to the power of 3? That's 8. Why this is what? 4, then minus 36. Again, this is not equal to 0. So this right here is not a solution. Let's try t is equal to 3. Let's see what some give us. So that would be 3 raised to the power of 3 plus 3 raised to the power of 2 minus 36. Will this give us 0? Let's see. 3 raised to the power of 3 is 27. And 3 raised to the power of 2 is 9 minus 36. 27 plus 9 is what? 36. Oh yes, this is equal to 0. So it means that t is equal to 3 is a solution. So let's go get our equation, which is this one here. Let's write it again. T raised to the power of 3 plus t raised to the power of 2 minus 36 is equal to 0. So what I can do here is to rewrite t raised to the power of 2 as this. Now watch this. I'm going to have two terms. When they add up, they will give me t squared. So I'm going to have this t raised to the power of 3 minus 3t squared plus 4t squared minus 36. The reason why I'm choosing this is because this will go with this, and then this will also go with this. When I factorize, I will get something common in the bracket. So let's factorize these first two terms. That will be t raised to the power of 2 because that's what's common. Then bracket t minus 3. Then plus 4t squared minus 36 is equal to 0. Now the issue is with these last two terms. What am I going to do here? I want to try as much as possible to get t minus 3 in the bracket with 4t squared and with minus 36. So I'm going to bring in two terms so that when I factorize, I will have t minus 3 in the bracket. See what I mean? So let me write t squared minus bracket t minus 3 plus 4t squared. Give me something. When I subtract it from this 4t squared and I factorize, I will get something. I will get t minus 3 in the bracket. It is what? Minus 12t. If you factorize this, you are going to have 4t bracket t minus 3. You see that? Now we cannot just bring in minus 12t from the blues and leave it like that. We must do something to counter us bringing minus 12t. So let's add 12t again to this. Of course, minus 12t plus 12t will give us what? 0. So it will be as though it never existed before, which is the case. So then I will now write minus 36 here, which is equal to 0. Where is this coming from? It's coming from here. So let's factorize now. That will be t squared bracket t minus 3. And then let's factorize this. Again, as you did before, 4t is common. You have t minus 3. What about these last two terms? Luckily for us, we're still going to have t minus 3 in the bracket. So that will be 12 bracket t minus 3, which is equal to 0. So we have t minus 3 common all everywhere. I'm going to factor that out again. So that's t minus 3 in bracket. And then what? T squared, which is from here, plus 4t, which is from here. And then plus 12, which is from here. All is equal to 0. So what does this mean? Using zero product rule, t minus 3 is equal to 0, which is this one here, or t squared plus 4t plus 12 is equal to 0. So I'm going to use the discriminant here just to be sure that we're going to have real solutions. We don't want to invest our time solving something that will not give us real solutions. So I will say the discriminant, which is denoted with this symbol, which is equal to b squared minus 4ac. Let's examine the nature of root. So if you compare this, if you compare this with the general form of a quadratic equation, which is what? Ax squared plus bx plus c is equal to 0. So the discriminant will be equal to, what is b? B is the coefficient of t, which is 4. So 4 squared minus then 4 times a. What's a? A is the coefficient of the leading term, which is 1, times, what is c? C is the constant term, which is 12. So the discriminant is 4 squared is 16 minus, what is 4 times 12? That is 48. And this is less than 0. So what does this mean? It means that this has complex solution and we don't need it. We're going to focus our solution to the real one, which is this one here. So I'm going to write t minus 3 is equal to 0. And then when I transpose negative 3 to the right hand side, I will have that t is equal to 3. So this is the value of t. However, remember we said that let m raised to power 3 be equal to t. And since we know what t is equal to 3. So it's going to be m raised to power 3 is equal to 3. For us to get the value of m, I'm going to take the cube root of both sides. So let's take the cube root here and the cube root here. So this cube root will get rid of the cube. So we have that m is equal to the cube root of 3. Now we need to verify our answer. So we'll test this into the original equation, which is m raised to power 9 plus m raised to power 6 is equal to 36. So since m is equal to the cube root of 3, let's plug it in here and let's see if it will give us 36. So the cube root of 3 raised to the power of 9, from here, plus the cube root of 3 raised to the power of 6. Let's see if this will give us 36. So you know that cube root of 3 can be rewritten as what? 3 raised to the power of 1 over 3. And because we already have an exponent of 9 here, we'll basically still multiply this by 9. So let's do that here. 3 raised to the power of 1 over 3 times 9. Then plot the same thing here. 3 raised to the power of 1 over 3 times 6. So 3 into 9 is 3. 3 into 6 is 2. 3 raised to the power of 3 plus 3 raised to the power of 2. And what is 3 raised to the power of 3? That's 27. And 3 raised to the power of 2 is what? 9. 27 plus 9 is what? 36. And that was the same thing we had right here. So yes, the value of m that will satisfy the equation is root 3. I hope you enjoyed this video. If you did, kindly subscribe to this channel, like this video, and share this video with your friends and family. I hope to see you in the next video. Bye for now.